Hey, so we are here looking at navigation and bearing and how it can be utilized to further extend our application skills in trigonometry. So we need to understand, first of all, how to read a bearing, and that's what this video is going to discuss. How do we read a bearing, and how do we use bearings to further extend our trig capabilities? So the first way we can read a bearing is, I have 4 examples here. So for example, 31 NE, 72 SW, and so on. So obviously we need to know where north, south, east, west are. Now, when I read this, NE, we need to read this as east of north. So notice how this 31 degrees from north is 31 degrees towards the east side. And looking at the next, this would be west of south. So we're at south, 72 degrees towards the west side from south. And then 38 degrees east of south. So from south, we're going towards the east, 38 degrees. And for the 45 degrees west of north, we would go from north west 45 degrees. So what if I gave you, say, 13 degrees, let's say SW. So understanding how we read that, this is west of south. So I would approach the problem by creating my north, south, east, and west marker. And from south, 13 degrees towards the west. And that is the direction, that is the bearing that my boat, plane, object, that's the direction it is traveling. Okay? So we often tend to want to read it as southwest, which might make you think it's 72 degrees south from the west, and it's the exact opposite. We read the second direction and then the first, west of south. All right, now this is navigation. How does a heading or a bearing differ? So a heading or a bearing, how it differs is it's an angle that for the line of travel that's always measured clockwise from due north. So where the previous up here, they can be measured from south or from north, a bearing or a heading is always from north. So let's imagine I have a bearing of 240 degrees. Notice the difference. I'm not told an east of north or a west of south or anything like that. I'm just told a bearing of 240 degrees. So how I would use this when creating my diagram, again, creating my north, south, east, and west marker. From north, always from north, I'm going to be turning 240 degrees clockwise. So clockwise, so this would be 90, this would be 180, 240 would be within this region. So do your best to not get your unit circle measures mixed here. The reason why we're reading the angles differently is because in the unit circle, if you remember, 0 degrees is on the far right, then 90, and then 180. So with bearing, 0 degrees is due north. You're going north if your bearing's 0 degrees. So let's imagine I have a bearing of 52 degrees. So we create our marker. So 52 degrees from the north. Well, I'm not even past this first region yet. So we have 52 degrees. Okay? And then for the last, what if I had 163? A bearing of 163. So we make our marker. So we have 90. And not quite 180, so we would be heading in this direction. All right. How do we use this, guys? How do we use this to actually solve a problem? So remember, in these videos, we're only looking at how we make the diagram. We'll come back to these again to look at how to solve them, but how do we make the picture? So I have 2 examples for us to examine. So let's say we have this this picture. Oh, you can go ahead and see the next one. It's fine. So a forest ranger trigonometry. Yeah, you like that? Trigonometry. At Ranger Station A, sights a fire in direction 32 degrees east of north. Ranger built for this at Ranger Station B, 10 miles due east of A, sights the same fire on a line 48 degrees west of north. So a couple of things from this. We are told that for trigonometry, Station A, he sights the fire at 32 degrees east of north. Then, at Station B, that is 10 miles due east of A, its line of sight is 48 degrees west of north. So we were given three things. When dealing with surveying, I'd say, just draw the triangle and place your labels on it. And then as you place your labels, then the numbers are confined where they need to go. Here with bearing, often we have to have our diagram a certain way. So we have, we'll say, the two stations. They're on east and west of each other. Station B is due east of A, so it's to the east of A. As a matter of fact, it's 10 miles due east. Okay? Due east. So then at A, we have a bearing. Make my little navigation marker. We have north. Okay. East of north, 32 degrees east of north. So from north, we go 32 degrees towards the east. And then from Station B, we have a bearing, or heading of 48 west of north. So we have our little north, south, east, west marker just to help us out. So from north, we're going towards the west, 48 degrees. So with our diagram, this would be where the fire is. Okay? So using bearing, the east-north, and making sure we use these little guides to help us with our navigation measurements. So let's look at the next. Oh, and by the way, so it says find the distance from each ranger to the station. It's from each ranger, so we'd be finding 2 measurements in that problem. But we're not solving it here, we're just creating the diagram. So let's look at the next one, and last one. So leaving from a harbor, so that's important, so they're leaving from the same position. 2 storage ships leave. Ship 1 leaves at a bearing of 285, and ship 2 leaves at a bearing of 30 degrees. All right, so let's start with that. So they're leaving from the same point. I'm going to use here my little guide for the bearings and navigations. You often see, at least whenever I walk through a problem, I'll put this rough north, south, east, west marker on here just to help me a little bit. So they're leaving from the same position. So let's use blue for ship A, or ship 1. So ship 1's leaving at a bearing of 285. Bearings measured from north, always going clockwise. So 90, 180, this would be 270, so 285 would be in this last region. I'm not going to say quadrants here. So in this last region, this is 285 degrees. And then for the next, for ship 2, I'll use green. For ship 2, it leaves at a bearing of 30 degrees. So from north, it leaves at a bearing of 30 degrees, which is not quite out of the first region yet. All right. So with this, we are told that ship 1 is traveling at 25 miles per hour. But I read further and it says for 3 hours. So this would end up being 25 miles per hour for 3 hours. That would end up being 75 miles. All right, and then the second ship travels at 30 miles per hour for 3 hours. 30, so that would be 90 miles. and we desire to know how far apart are they. So we desire this distance. So when looking at this problem, notice how we have a 30-degree angle measure on the inside of the triangle, and it's 285 on the outside. So how we would actually get this this unknown piece here is we would take 360 and take the 285 away. Okay, so thinking of this, I believe this would be 75. Let's just think of this for a moment. So 60. So this is 15 away from. This is 15 away from 300, and then 60. So that'd be 75. Yep, 75. So we have a 75-degree angle measure. And really, this is really messy, guys. Really messy. So there's no harm. Once you figure out all of your angle measures, there's no harm in redrawing the picture where it's much cleaner. So we know that this right side is going to be 90 miles. The left side is going to be 75 miles. We desired to know this top segment, and we now know that the inside angle, one side's 30, the other side is 75, so that would be an inside angle of 105 degrees. And from there, we can easily identify what we use it to find the unknown length. And coming back up top, speaking of getting a simpler diagram, coming back up top, so looking at this diagram, we'll end on this. Notice the angles that we have, the 32 degrees east of north and the 48 degrees west of north. Notice how they're not even within the triangle. They're two angles on the outside of the triangle. Now, within our little guide, there's 90 degrees within each section. There's 90, 90, 90, 90. So I could take to find this inner piece, we could take 90 and take the 32 away. So doing so, we would get 58. All right. And then same idea up here, 90, take away the 48, we would get 42. Because of the right angles that are formed within each region. So redrawing this figure much simpler. We have a 10-mile separation between A and B. And then we would have, let's see, 58 degrees and 42 degrees. And our fires up top. All right, so when dealing with bearing or a heading, it is naturally going to take a little bit longer to get the diagram, but I highly encourage, once you get all of your measurements, because bearings often aren't used in a problem. I mean, we have an exception down below here on the second problem, but bearings often are used to get the angle that you need. So when you have the angles that you need, I would recommend redrawing the triangle much cleaner and then using that picture to solve the problem. So best of luck, guys, when dealing with problems that deal with bearing and heading. Do not give up. Keep pushing through the problems. Do your best. And I'll see you in the next version, next video we have here when we look at vectors. So stay tuned for that video. I'll put a link here on the end of this so you can go right to it. And I'll see you then.